Hi everyone, I'm Alex from LinkedIn, and today I'm going to talk about how we do deep personalization on our job marketplace at LinkedIn. The background is that a few years ago, our stack was all over the place, our ML stack, and we decided to unify everything under TensorFlow, and we took this opportunity to streamline how we do personalization across our modeling stack. So when we look at our marketplace, we usually look at it through the lens of three personas. The first one is job seekers. So each week we have dozens of millions of job seekers that comes to LinkedIn to search for a job. Second persona that we looked at are hiring managers that post jobs on LinkedIn. We have millions of jobs that are always open at LinkedIn for people to search through. And the third persona that might not be obvious at first is just LinkedIn that do the matching between those job seekers and those job posters. It might seem simple at first, but when you look at the screenshot on the right, there's 3 or 4 products already that are powered by AI that help us match people with jobs. The one that is the most prominent there is job recommendations, which you see in the middle of the screen, where we look at our members and we match them with jobs straight away. The second product that's in the screen is job search. So the search bar on the top, if you type some keywords to search for jobs, we have another model that will help you find the right jobs given your query and the context that you provide us. We also have job alerts. So you see there's notifications at the bottom. So we have other models that decide which jobs are valid for us to send as notifications for you to apply to. And if you scroll down a little bit on the screen, you'll see promoted jobs. That's another family of model. Up until 2 years ago, all of these models were developed by different teams. It means that all of these models have different stack. We're learning from different data sets, and we're doing personalization slightly differently across the board. So it made us difficult to create leverage and to create a consistent experience. So today we'll go through how LinkedIn models its job seekers. That's the main place where we do personalizations. We'll then move to hiring managers, how we do understand what hiring managers want from LinkedIn, and we'll finish with how we do match and some learnings that we had along the way to scale personalization. One of LinkedIn's biggest assets is its collection of member profiles. So when people come to LinkedIn, they tell us who they are, they tell us about their career, and this is the main thing that we use when we do matchmaking at LinkedIn for jobs. The things that we're looking for are the job titles that you've had throughout your careers. We're looking for a location, the place where you worked at. We're looking for companies you worked at, and we're also looking for your skills. For skills, we use the skills that you give us on your profile, and we also have some models that infer the skill that we think are relevant to your experience. I think it's a good segue to start talking about LinkedIn's economic graph. So LinkedIn economics graph is the lens through which we look at all of the entities on LinkedIn and we connect them together. So for our economic graph, things that are relevant for the job marketplace, we have a taxonomy of thousands of titles. So when you're on LinkedIn, we look at your profile and we map you to one of these titles. We do the same thing with our jobs. We have taxonomy of skills. We have taxonomy of companies with attributes we know about them. We have taxonomy of location that allow us to organize our geographic knowledge. And this economic graph just connects everything together at LinkedIn based on these attributes. We connect member together together. We connect member to skills, to titles. We connect jobs to the same kind of nodes. And we have a big team of researchers at LinkedIn that works on keeping this graph up to date. We did a lot of mileage on just the economic graph, understanding what it is, looking at title ID, skill ID, and how those things can predict and personalize your experience. One place where we hit a limit is when we use sparse attributes, we don't have exhaustive view on everything that you have, right? So if you tell us, let's say that you know the TensorFlow skill, it probably tells something about your knowledge of AI, your knowledge of Python, and those things are hard to encode in a sparse representation, like just a one-hot vector of the skills that you have. So when we move to deep learning, that's one thing that we we were able to leverage getting better representation of each of those entities, how they relate to each other, and specifically how they relate to each other when you're searching for jobs. The second thing where we add some improvement from deep learning is just ambiguities. If you look at those job titles, even in my profile, I went from principal researcher at a small company back in Montreal to senior software engineer at LinkedIn. Those transitions don't happen in any kind of context. So for small companies, you can have a titles that weight more in seniorities, moving to titles that weight less in seniorities to bigger company, but the inverse is not happening as often. So just having deep learning and automatically inferring what's the interaction between all of our sparse features that we know for our economic graph gave us some good wins along the way. The second thing that we leverage for personalization outside of dense representation is just text understanding. Even if we maintain our taxonomy, the jobs marketplace is moving fast and there's always new titles that are coming up. For example, there's a lot of presentation about MLOps. That's a title that didn't exist a few months ago, well, a few years ago. Going to text understanding directly allows us to just adapt faster in our models. It also allows us to go beyond titles. So our taxonomy is very precise in some domain. Some other domain we can leverage text to disambiguate what a title is about. Up until now, we talked about personalization on top of what people tell us of who they are and what they want. One thing that we learned a few years ago is that it's very difficult for people to be precise in telling us what they want. So if I ask you, what title of jobs are you searching for? You might come up with a title you think is relevant, but as soon as you start searching for a job, you see that there's a lot of way to say the same thing and that people will use different titles in different contexts. So our best mechanism for personalization is just letting people show us what they want and try to learn from what they tell us. So we have features for we have features that looks at your activities on LinkedIn. So we look at what kind of jobs you applied on recently, what kind of jobs you saved, and what kind of jobs we dismissed. And we use two kind of features for these. We use all of these standardization features that I just presented. We learned that using these help us memorize the kind of jobs that people are looking for. So it helps us to have more precise personalization. We also use aggregation over embeddings of the jobs you interacted with. So we have sequence modeling in place. So it helps us learn a more generic pattern over what you're doing to better predict what you want. And using those activity features also allows us to have real-time personalization, so we can update our knowledge or your log of activities in real time and just have a faster feedback loop to adapt what we're presenting you. Just spending a few minutes on real-time personalization, there's two ways to do real-time personalization, at least at LinkedIn, that we explore. Up until a few years ago, the way we did real-time personalization was to train personalized model for each of our members. So it means that every day we would aggregate all of your data, put them on our grid, train a model for 15 to 20 hours, push the model out online, and then the day after you would get models that are updated with your activities and more precise recommendation. This was challenging for us for a couple of reasons. The first one is the feedback loop is long in this case, at least for us, because we needed to send our data offline, train, send back online. So when people were acting and providing us feedback, it took us a very long time to just adapt to this feedback and try to zero in on what people really want. The second thing that made it challenging is that it was per model personalization. So there was no generalization across models or across product. And it was also more difficult to operate. So we often have tens of models that are ramped at the same time. So just retraining 10 variations of each of our model, large model for personalization was difficult. So the decision we made when we moved to deep learning model was, instead of using those activities as labels to a model that we train, we use them as features in a log of activities. So it made our model smaller and easier to manage. The second thing that it did, it created leverage across our product. So it means that if you do something in the job search product, we now have access to your activity log when we do job recommendation or job alert. So we can have this economy and this impact at scale. And now that we add that at scale, it just made sense to invest in real time because the payback was there. And it opened up the door for better product experience as well. So we don't do AI in a vacuum. We can work with our product managers to say, now that we adapt our model in real time, let's provide the experience in the product to leverage this real-time interactions and get better feedback loop in place in the product. So that's how we do modeling and personalization on top of our members. We look at their profiles, we look at what they tell us, but the most useful thing we found is look at what they show us they want and try to adapt to their activities. For job postings, we have a very similar set of features. Like I mentioned, we leverage our economic graph, so we know title, location, company, skills of a job. We also use embeddings for dense representation, so we have a similar playbook than the one that we have for members. And for activity features and personalization, that's something that's a work in progress right now. So most of our personalization so far are understanding what our job seekers want. We're now pivoting to understanding what our job posters want. And we'd like to create a feedback loop where when people post a job on LinkedIn, get their first few applicants and tell us what they like and what they don't like, we can feed this information back to our job recommendation, job search system, and zero in on this match between job posters and job seekers. Matchmaking. What's a good match? One thing that's challenging about the job marketplace, if we compare it to other kind of marketplace, is we need to create we can only create one match for each of our job seekers and one match for each of our job posters. So usually when you search for a job, you might apply on many jobs, but you'll have success with only one of them most of the time. And so you'll be hired for one of them. Our hiring managers are the same. Each time they post a job, most of the time they're just searching for one person. So it makes it a bit different than, let's say, running an ads marketplace, where if we convert many people, it creates value for the people that are posting the ads. For us, our job posters will get value only from one member. So it means that we cannot just optimize for the jobs you want or the number of applicants. We need to optimize for the whole process up until you're getting hired. It's just prevent us from using some of the modeling approach that we experimented with in the past. For example, a few years ago, we had a collaborative filtering model that was running job recommendation. And what it did is just identify jobs that were very popular and create even more engagement on top of those jobs. And we ended up with jobs that had tens of thousands of applicants. And at this point, it just becomes unproductive, both for job seekers to apply there because there's so many people that are already applying on these jobs, and for job posters to go through all of these applicants. So when we do our matchmaking now, we try to optimize for people getting hired. Our challenge is that it's not a signal in which we have full visibility, and it's a delayed signal even for when we have visibility. That would be a subject for another talk, but if you have those kinds of problems as well and you want to share notes, just let me know, and I'm happy to discuss about how we think about it and learn from how you do those kind of optimization on matching, not on volume, but on the quality and with limited inventory. So all of what I presented so far can be summarized, I think, in this architecture. We have our embeddings. So I talked about dense representations that we have for member and jobs. You can see them in the green box there. So for this architecture, we use the same templates for all of our product at LinkedIn now. So instead of having many products using different stack and few leverage across features, we now have streamlined our stack to this template. So we have embeddings that are shared across all of our product line for members and for jobs. So it helps us in two ways. It helps us learn across all of the data that we have for jobs at LinkedIn. Second place where it helps us is it's content-based recommendation. So our jobs comes and go. They stay on LinkedIn maybe for 30 days, then other jobs are posted. Same thing for member. Once they find a job, they just move to to their jobs and they stop searching. So having those content-based embedding in place just help us with the cold start problem. So we already have something that's working just based on content. The second thing that we have is those activity features that I mentioned earlier. So the feedback loop on top, we do recommendations to our member interact with them, and within a few seconds, the activity log is available to all of the other product that we power at LinkedIn to do personalization. And we have a personalized DNN on top of it, so the blue box. For each product, we have a different model that we train on top of these features. This is something that we're working on right now. So we're starting to explore how we can use multitask learning instead of having custom towers on top of each of our model. If you have experience with multitask learning, powering different product, and how you do trade-off around those products, I'll be very happy to discuss with you. So what we learn in our transition from very heterogeneous collection of tech stack and way to deal with personalization to a more streamlined modeling approach around TensorFlow and around personalization. We learned that real-time features, real-time activity features are easier, at least they were easier for us to productionize than trying to do real-time learning on top of a collection of model. This also allowed us to create leverage across product, and it made our investment in real-time even more worth it, and our investment in modeling activity features more worth it as well because of this leverage and economy at scale. We learned that cold start problems can be addressed with a mixture of content-based embeddings and activity features. So we learn about our member, but the experience becomes much better when we also learn about what they're doing, and we create this feedback loop in our product. And once we have a good feedback loop in place, we can work with our product partner to reinforce it within the product and then make the product experience even better. We learned that another way to get a good return on investment across our product line was to share those embeddings that I just mentioned about. So we can learn content representation once and push it to many models at once to get wins across our product line. And another thing that I mentioned a little bit is we need to be careful about what we optimize for. So we're spending more and more time to think about what we want our models to do. So we don't optimize just for people applying on jobs anymore. We optimize for them getting the jobs. And the way we think about this optimization is through labels. So how do we reward our models, or how do we tell our model they're doing the right or the wrong thing? So that's an area where we're investing actively right now. That's all I have for today. Thank you.